The goal of this video is to talk about how to, let's say you have a field mapping lab. Let me get started with a screen share. Screw it. Let's see, where are we here? Is it this one? Whoops. That's driving me crazy. Let me get this over here on the screen share. So imagine you're doing a field mapping lab, all right? And we're going to make a bunch of voltage data. That looks a little bit like this. So at a bunch of different points, you record the voltage using a probe in lab. So that's easy to measure. We've measured all these voltages on a grid. So once you do that, we could use the following information. I know that the electric field X component should be opposite change in voltage over change in X. Similarly, we could have the electric field Y component using this way. And so let's look at our data and see what we've got here. I want you to think about the information going down this direction as the change in Y. And over here, this is things changing in X. Now, in order to make this data work, just like when we're doing kinematics, oftentimes the first or the basically the first row ends up being a throwaway row, and the first column, similarly the last one. You'll see why when I do a numerical difference. So what I'm first going to get started on is I'm just going to blank out the electric field all the way around the edge here. And I think, oh, let me make this full screen. All right, so what I'm doing is I'm just making a border for me to follow. And if you're curious how I knew, I just checked this in advance. So what I'm doing right now is I'm just notice this is a, whoops, when I highlight this, if you look over in the name box, that's 15 rows, 15 columns, and also 10 rows. So I have that shape data. And so what I've done is I've just made sure this is also 10 and 15. Okay, so I'm not able to figure out the uh, electric field X component accurately for any of these values, and you'll see why in just a minute. I'm going to use the formula, and I'm going to bring this up here again. I'm trying to use this formula and make that bigger. I want to use the change in voltage over the change in X, and remember this minus sign. Okay, so when I do that, I'm going to click into this cell. I'm going to type equals to do a calculation. I'm going to remember that minus sign, and I want to do change in voltage divided by change in X. So I've got a couple of terms to fill in here. So this information was recorded using a 1 centimeter grid. Keep that in mind. So now I'm going to click on, let's see, if I want, now let me say this again. If I want to get the electric field that corresponds to this point, I'm going to use the change from just after to just before. So in this cell right here, I want to reference this cell and that cell. I hope that is coming through on a Zoom video. Again, if I want to figure out the electric field in the X component right here, I'm going to say this is equal to negative of this voltage minus that voltage. So just after to just before, and then I'm going to divide in this case by the X spacing. Well, if every grid is spaced by 1, there is now 2 units of spacing. So this electric field that I have written here is actually the electric field in units of volts per centimeter based off what I use. So keep that in mind. So now all I have to do is just fill to the right, fill down. Is there a way you could do this in MATLAB? Absolutely. Notice, let's check what are these zeros going on there. Let's click on that. Oh, there's no change in voltage. The electric field should be 0. Now you could be saying, well, dude, you could have got this information down. Oh, whoops. Let me get out of there. Yes, I could have figured that out, but I don't want to. More on that some other time. But now you should be able to follow a similar procedure to get the electric field in the Y direction. So, for example, you should think about what you would need to type in this cell to get the Y direction. Go ahead and try it right now. Pause the video. Okay, here's what I'm going to do. Equals negative of change in Y over change in voltage over change in Y, which was 2. Well, I'm going to pick for this cell, I want the higher voltage minus the lower volt. Well, not the, I guess I should say it this way. I'm assuming that this first row corresponds to Y equals 0 because that's the way MATLAB will do it. It'll flip your contour plot upside down. So for me, it doesn't really matter, but basically I'm going this one minus that one for this cell. All right. So equals negative uh, larger value of Y's voltage minus lower value of Y's voltage, divide by the spacing, which in this case was 2 centimeters. So I can get this. That is how you generate this data. Fill to the right, fill down. And now I've got all my data to make an electric field plot, not just a voltage contour plot. That's enough for this video.